Hello, so this is Mr. Hakim just going over the paper one for the IGCSE Chemistry grades 9 to 1. For this, it says you need a calculator and a ruler. The paper is out of 110 marks. I'm going to do a little walkthrough of this exam paper so that it becomes a little easier so that you know what teachers think like when we mark when we answer exam papers ourselves, and then you can have an idea at doing your own one. So I am going to be using a red pen. I do also have a green pen and a pencil at points. Of course, you need to do this in either black or blue pen when you are doing it with the real thing. This is the January 2023 paper, and hopefully it comes out clear and you can see it as we go along. This one of the key ideas is when looking at these exam papers, when you are doing them as a revision, make sure that you set yourself some good time limits to make sure that you are doing it under exam conditions. And then with the correct amount of time. So the more practice you have, the better you're going to be in the actual exam. Read the exam questions carefully. Sometimes read them twice, if not three times, four times, until you really understand what is the question actually asking me to do. Okay. So this question is about the three states of matter: solid, liquid, and gas. Diagram shows how particles of a substance are arranged in two of these states: solids, liquid, solids, and gas. These are already done for us. The first part of the question says complete the diagram to show how particles are arranged in the liquid state. Now I'm going to take out my pencil. You will need to have a pencil. In a liquid state, what I'm going to do is I'm going to draw my spheres or my circles similar size to the ones that they have already provided. Now, I'm going to make sure there are just certain rules that you need to remember when filling out your spheres. You, they don't need to be perfect, but they all need to be approximately the same size. They do, however, need to be at the lower part of the square. Okay, so I am going to leave the top of the square empty, just to show that, when I do pour a liquid in a particular container, it sinks to the bottom. It stays at the bottom. It fills there. It takes the shape of the container. It takes the shape of the bottom of the container until I fill it up all the way to the top. This will give you the 1 mark. Make sure that the particles are at least touching some other particles, and that they're not separated. There are no huge gaps like they do exist in the gas state. Second question says identify the state of matter that contains particles with the least energy. Now I'm going to go ahead, just write down solid as the answer for this one. Because in solid, the particles are moving the least. It tells me that they have the least amount of energy. Next question says the table shows two changes of state. Complete the table by giving the name of each change of state. Now, let me move this up a little bit so you can see the table a little bit better. So from a solid to a liquid, this is a recall question. We know this. This is melting. Write your answers clearly, write them in the boxes. Solid to a gas, that is called sublimation or sublimating. I'm going to write sublimation, that's the name of the process. And finally, question C, excuse me, says explain why hot water evaporates more quickly than cold water. Now, this explanation, you have to include that particles, they have more energy already in the hot water, and therefore less energy is required to overcome the forces that are holding the particles together. Okay, so 2 points for 2 marks. The first point, particles already have higher kinetic energy in hot water. And the second point, less energy is needed to overcome the forces between the particles. Remember, in evaporation, the particles they have to completely overcome the forces that are holding them together in this liquid state, so that they are free to move and turn into that gas states. So each one of these will give you 1 mark, and that's your 2 marks there. So this is question 2. It says it's about elements, mixtures, and compounds. Which of these is the formula of a molecule of an element? Now, correct answer would be Cl2. That is the formula for one atom. This is more like the symbol. That is the formula of a molecule of a compound, not an element, and the same for H2O. That is also the formula of a molecule of a compound. 2b says which method can be used to separate an insoluble solid from a liquid? Insoluble, let's keep use that as a underline that. From a liquid, insoluble, that is a keyword. It means it has not dissolved. So just list things, if they are things that don't dissolve in a particular water of your liquid of your choice. You can use water, for instance. Now, but I suppose we can also do Lego. Lego, I believe, also does not dissolve in water. So how would you separate them? And then the thought process becomes a bit more clearer. You're going to go directly for filtration to use that. 2C says, give the name of the method used to separate a mixture of liquids with different boiling points. Now, this one you have to write down because it says different boiling points. We must write down fractional distillation. If you had written just distillation, you would not get the mark, unfortunately. Or if you had written simple distillation, because they serve different purposes. Okay, particularly simple distillation, when we have done separation techniques, it just separates one particular type of liquid from an insoluble, from a soluble solid. Suppose salt water, if we are only interested in the water, we use distillation. However, if we have a mixture of different liquids with different boiling points, we have to use fractional distillation. Now, 2D says a student adds a crystal of substance X to some water in a beaker and leaves the beaker for 1 day. The diagram shows the beaker immediately after adding the crystal and after 1 day. The question says, which equation gives the correct state symbol for a process that occurs in the beaker? Now, let me just put this a little bit down so you can see it. Now, out of these equations, we know that the substance started with a solid, so it could either be any of these. C is definitely not the right one. We can rule that one out. Now, at the end, the substance didn't turn into a liquid. That's not the right answer. It also did not evaporate as well. So we can rule that one out as well. So that G means gas. Just quickly write down your state symbols, always to remember what they mean. So G, gas, solid, liquid, and I'm going to leave AQ as aqueous. It means dissolved in water. Which other process occurs in the beaker? Apart from dissolving, we also have diffusion as well. Substances do move from an area of high concentration to an area of low concentration. Part 3. After 1 day, the student does 2 tests on the liquid in the beaker. The table shows the students' results. So they've done a flame test, a lilac flame, straight away. They should tell you it's got something to do with potassium, right? Because you remember, potassium is associated with the lilac flames. And then the next one, it says acidified barium chloride solution. Okay. Now, the barium chloride solution, therefore, is going to give us the answer as some sort of a sulfate because the white precipitate is formed. We're just essentially going to identify that as potassium sulfate, and that will give us the 2 marks. Even if you had written potassium down, that would be 1 mark, or sulfate down, that would just give you another 1 mark. However, if we write it out as potassium sulfate, that compound, that will give us 2 marks because we've used both of the tests to identify. This next question is about gases. Name the gas that is about 1% of dry air by volume. Now, This you need is again just a simple recall question. You take it from composition of air. The gas that is about 1% is argon for 1 mark. Which is the most abundant gas in dry air by volume? So again, about 79% or something. It is nitrogen. Another recall question. Um, Question B says a student uses this apparatus to find the percentage by volume of oxygen in a mixture of oxygen and neon. This is the student's methods. Do pause it here and have a read. It is time to pray, so I'm going to pause the video.